So exponential functions are in the form y equal a times b to the x. X cannot be equal to 0 and b is positive. For exponential growth, b has to be greater than 1. And then for the exponential decay, same equation, y equal a times b to the x. But now b is greater than 0 and less than 1. So B gives you either the growth factor or the decay factor. For example, if I have $1,000 right now in a bank and the exponential growth function B is 2, that means it's double. By next month, I have $2,000. By the next month, I have 2,000 to the second, it's 4,000, it doubles, and then 8,000 and such. When you talk about exponential function, it goes slow in the beginning, but then it starts to double, it goes pretty fast up. So that's the exponential growth. And exponential decay, if the growth factor is half, if I start with 1,000, and then half of 1,000 is 500, half of 500 is 250, the graph is going down from left to right. Once we make a table, you will get it even a little bit more. So an asymptote is a line that the graph approaches closely, is a line that the graph approaches closely. So here's the first example. Graph the function y equal to the x, state the domain and range. First of all, your a is 1 that we don't see. A is 1. And the growth factor is 2. 2 is greater than 1. 2 is greater than 1. So that means we have an exponential growth. The exponential growth here, b is 2. So let's make a table by selecting a few values for x and finding the values for y. For the exponential function, look how x goes from negative infinity to positive infinity. So we're going to use negative 2, negative 1, 0, 1, 2. So the domain for the exponential functions are always all real number or negative infinity to infinity. We're going to use in our table our 5 numbers, or sometimes if the table only has 3, choose negative 1, 0, and 1. You don't have to use all 5. So let's plug in negative 2 into x and solve for y by hand. So 2 to the power of negative 2. 2 to the power of negative 2, this is the same as 1 over 2 squared, which is equal to 1 over 4. If you substitute negative 1 into x, you get 2 to the negative 1, which is equal with 1 over 2. 2 to the 0 is 1. Any number to the 0 power is 1. 2 to the first power is 2, and 2 squared is 4. So negative 2 1/4, negative 1/2, 0, 1, 1, 2, 2, 4. Draw the horizontal asymptote at y equal to 0. Y equal to 0 is the horizontal asymptote. So my graph goes above the horizontal asymptote. It approaches it closely but doesn't cross it. You connect the points with a smooth curve. Either from the table or from the graph, what is the range here? Above 0. So the range is y is greater than 0. 0 is not included. Or if we write it as interval notation, we have 0 to infinity. 0 is not included because of that asymptote. It doesn't cross 0. So make sure you have a parenthesis here around 0. You can use either of the notation. You don't have to use both of them. I prefer the interval notation. If the graph it's above 0, 0 to infinity. If it's below 0, negative infinity to 0. So this is the parent function of the exponential function. It's a curve going up from left to right. Now, just like any other functions that we learned, linear, absolute value, rationals, the one that we just had a test on, you're going to have translations h and k. Remember, a tells you stretch or shrink. B now tells you growth or decay. H, you go left and right opposite of the sign, and k, up and down with the sign. So to graph exponential function, first you graph the parent function, y equal a times b to the x. Then you translate the graph. If it's negative age, you go into the right age unit. If it's positive age, you go to the left age units. And then the same thing with k. If it's negative k, you go down. And if it's positive k, you go up k units. In the parent function, the horizontal asymptote was 0 because my graph was not translated. I did not have any k. I did not have h or a k. So I didn't move my graph up or down. So the horizontal asymptote is a 0 because I didn't have any k. But if we have a k and we move the graph up and down, the horizontal asymptote will be at y equal to k. This is very important. The horizontal asymptote will be at y equal to k. So if I move the graph up 2, the horizontal asymptote will be y equal to 2. If I move the graph down 2, the new horizontal asymptote will be at y equal to negative 2. So graph the function y equal negative 2 times 3 to the x minus 2 plus 2. State the domain and range and the asymptote. So we're going to begin sketching the parent function, which includes the a, b to the x. So this one right here. This is where we're going to put in negative 1, 0, 1. And then we're going to translate the graph. So I'm going to take negative 1 and put it into the parent function. So y equal negative 2 times 3 to the negative 1. So that's the same as negative 2 times 1 over 3 to the first, which is negative 2 over 3. Then we're going to substitute 0. So y is negative 2 times 3 to the 0. Any power to the 0 is 1. So the answer is negative 2 times 1 is negative 2. And then the last one, y equal negative 2 times 3 to the first power, which is negative 6. So in this instant, we're going to graph the parent function, then with a dash line, and then we will translate the graph. So let's graph first the parent function, this function, before we're going to translate right to up to. So negative 1, negative 2/3, 0, negative 2, 1, negative 6. So the parent function does not cross 0. Now, before you translate and take every point, remember age, you go opposite of the sign, right 2, then we're going to go k is positive 2 up 2. So write 2 up 2. Before you do that, I think you should do first, draw your horizontal asymptote, which is y equal to k, y equal to 2. So the translated graph will not cross this horizontal asymptote at y equal to 2. So go on y equal to 2. Graph your horizontal asymptote first. And now we're going to take every point from the parent function and move it right 2 up 2. So right 2 up 2, right 2 up 2, right 2 up 2. So this is the translated graph. This was the parent. This is my new function with the translation. So the new function should be below y equal to 2. Since we have a negative in front, it flipped. The domain for the exponential functions are always negative infinity to infinity. We always pick -1, 0, 1, and such. And now the range here, we're talking about the domain and range of the new function, this one here. Now the parent. This one is y is less than 2, or from negative infinity to 2. Y is less than 2, or negative infinity to 2. Negative goes first on a number line before 2. Any questions before I flip? So number 3, if you look at B here, 3/5 is between 0 and 1. So this is also dk. And then number 4, the same thing. I'm actually going to do number 4 first. 2/3 is between 0 and 1. So this is also a decay problem. So we're going to do 4, then come back to 3. Because 3 has a negative, 4 doesn't. It's a positive. So I want to show you the decay with a positive coefficient first. So we're going to begin by sketching the graph of the parent function y equal 3, 2/3 to the x. So you stop after x. You stop after x. So -1, 0, 1. So if you do this mental, 3 times 2/3 to the -1. This is the same as 2 to the -1, 3 to the -1. To make them positive, don't you just flip them? So it's the same as 3 over 2 to the first. You flip the fraction to become positive. 2 to the -1, 3 to the -1, you flip them and they become positive. So then 3 times 3 is 9 divided by 2. So 9 over 2, which is 4.5. Then we have 3 times 2/3 to the 0. It's 3 times 1, which is equal to 3. And then 3 times 2/3 to the first, 6 divided by 3 is 2. I go 3 times 2 is 6, divided by 3 is 2. So now let's graph. The graph should start in the top and coming down from left to right. So -1, 4.5, because it's a decay. 0, 3, 1, 2. So this is the parent function of this particular graph. Now we need to translate +1, age is +1, so we're going to go left 1, down 3, k is -3. But before we do that, I'm going to put my horizontal asymptote y equal to -3 on the graph to make sure I don't cross it with my translation. So y equal to -3. So now we're going to take every point, left 1, down 3, left 1, down 3, left 1, down 3. Any questions? The domain, negative infinity to infinity. So now let's look at the range. So I'm looking at the range of my new function. Y is above negative 3. So y is greater than negative 3, or in interval notation, negative 3 to infinity. Negative 3 is not included. The graph is approaching closely, but is not included. You can use one or the other. I prefer you use interval notation to get ready for pre-calc. So the first problem we did on number 1, that was exponential growth. The graph went up from left to, so the growth was like this, went up from left to right when b is greater than 1, so that's growth. If b is between 0 and 1, you have an exponential decay. The graph goes down from left to right. So this is decay, and this was growth. Okay. Now we're going to move on to number 3. We have a decay here, but then the graph flips because of the negative. So again, we're going to sketch the parent function, negative 1, 0, 1, into this parent function. You stop at x. So negative 2 times 3 over 5 to the negative 1 is the same as negative 2 times 5 over 3 to the positive 1. Flip the fraction. So now negative 2 times 5 is negative 10 over 3. Negative 10 over 3 is the same as negative 3 and 1/3. And then if you plug in a 0, negative 2, 3/5 to the 0 is negative 2 times 1, which is negative 2. And then negative 2 times 3/5, that's negative 6 over 5, which is negative 5 and 1/5. So negative 1, negative 3 and 3/5, 1/3, 0, negative 2, 1, negative 1 and 1/5. So this is the parent function. And now we're going to translate. You can have graphic calculator now. And now we're going to translate every point. Age is negative 1, so write 1. K is positive 1, up 1. So write 1, up 1. Write 1, up 1. Write 1, up 1. And the asymptote is y equal to k, y equal to 1. So here's the new graph. It overlaps a little bit, which is okay. So the horizontal asymptote is your y equal to k, y equal to 1. So the graph should be below 1. Domain negative infinity to infinity, and the range here is y is less than 1 or negative infinity to 1. So the range is negative infinity to 1. Negative infinity goes before 1 on the number line. I'm going to teach only the two formulas because there's story problems tomorrow on the homework, tonight on the homework, I just want to write this formula to remind you from Algebra 1. Do you remember the exponential growth model for story problems? You had something like this: y equal a, 1 plus r to the power of t. A was the initial amount. R was the rate, and t is time. There's two problems in the homework for 6A1 notes. They're story problems, so that's why I'm just doing the formula and the first story problem. In the last 12 years, there's an initial population of 38 buffaloes in the state park. So my initial amount is 38. Y equals 38. A is 38. The population grew by, so 1 plus 7%. So the rate is 7%, but we have to rewrite this as a decimal 0.07. Write an exponential growth model given the number of n buffalo after t years. So we're going to leave t as it is. So this is your exponential growth model. Y equals 38, 1.07 to the power of t. So with this model, you can find how many buffaloes were in a park after 7 years, after 9, after 20. So one more time, the initial amount, initial population was 38. 1 plus r, the rate was 7%, I changed that to 0.07. And then you add 1 plus 0.07. About how many buffaloes were in the park after 7 years? So y equal 38. 1.07 to the power of 7. We're going to plug that in the calculator as it is, and you get 61 buffaloes. You round, obviously. And that concludes 6A1 notes.